Hello friends, I welcome you in lecture number 4 on counting. In this lecture also we will discuss one more example on product rule for counting. So we understand this example. How many one-to-one functions are there from a set with m elements to a set with n elements? So in this example we are asked to find out the number of one-to-one functions from one set to another set. Now in one set we have m elements and in another set we have n elements. So suppose this is set A which has m elements denoted by A1, A2, A3 and so on Am, and on another side we consider another set B and it is having n elements, so we denote them by B1, B2, B3 and Bn, and we have to count the number of one-to-one functions from set A to set B. So we recall the definition of one-to-one function. A function from A to B is said to be 1, if distinct elements of A have distinct images in set B. That is, if we take any two elements from set A which are different, then fx and fy must be different. The images of different elements must be different. That means no two elements can be assigned single element. We cannot have this type of situation that we assign, just a minute, we cannot have this type of situation that A1 is assigned to B1 as well as A2 is assigned to B1. For one function we cannot have two elements having same image. Here A1 is assigned B1 element and A2 is also assigned B1 element. That is, A1 and A2 are different but their image is same. So this type of situation is not allowed for one functions. So with this definition in mind, we have to count the number of possible one-to-one functions from set A to set B. Now suppose here number of elements in set A are m and number of elements in set B are n. Now suppose m is greater than n, that is number of elements in set A is more than the number of elements in set B, then we cannot have any one function from A to B because m is greater than n. Suppose I have this type of situation. Suppose in set A I have 4 elements and in set B I have 2 elements. So I cannot have any one function from set A to set B. For example, suppose we consider image of A1 as B1 and image of A2 as B2. Then for A3 and A4 the possible elements are from B1 or B2. So image of A3 must be either B1 or B2. So if we have number of elements in domain is greater than number of elements in codomain, then at least one element will be there such that it is assigned to two elements. So here we can say that this B1 is assigned to A3 as well as A1. So A1 and A3 are different but their images are same. F of A1 is B1 and f of A3 is also B1. So if number of elements in domain is greater than number of elements in codomain, then there is no one-to-one function from set A to set B, because for function we must assign element of set B to each element of set A. Now if these elements are more than elements in set B, then there will be at least one element in the set A which is domain such that its image is also image of A1 or image of A2. So in this type of situation, there is no one-to-one function from set A to set B. So there are two possibilities. Number of elements in the domain is bigger than number of elements in the codomain, that is m is greater than n, and in this case there is no one-one function from A to B. Another possibility is number of elements in set A is less than or equal to number of elements in codomain, which is n. So we try to count the number of one-one functions in this situation. Number of elements in the domain is less than or equal to number of elements in the codomain. So here we assume that we have this type of situation. M is less than or equal to n, or n minus m is non-negative. So now in this situation we have to count the number of one-to-one functions from set A to set B. So for that we have to assign element of set B to elements of set A. So for that we start by starting from first element of set A. First element of set A is A1. So for A1 we can assign either B1, B2, B3 up to Bn. There are n elements in the codomain. So image of A1 can be any of these n elements, or we can assign any of these n elements to A1. So for A1 there are n possible images, B1, B2, B3 up to Bn. We can assign either B1 or B2 or B3 up to Bn to the first element. Now for second element, suppose we have assigned B2 element to A1. Then for second element we cannot assign B2, because if f of A1 is B2 and f of A2 is also B2, then we can see that A1 and A2 are different but their images are same. So therefore function will not remain 1, 1. So because our function is 1, 1, we cannot use the image assigned to A1 for this A2. So we cannot assign B2 element to this second element A2, but we can assign B1, B3 up to Bn. So there are total n elements and we cannot assign this B2, so we have to subtract this one element. So for A2 there are B1, B3 up to Bn, that is n minus 1 images possible. So we can assign n minus 1 images to second element A2, or value of the function at A2 can be selected in n minus 1 ways. Value of the function at A1 can be selected in n ways. Value of the function at A2 can be selected in n minus 1 ways. Now we check for third one. So for A3 we cannot use the images assigned to A1 and A2. So two images or two elements of B are already assigned to A1 and A2. So the remaining possible elements are n minus 2. We have to subtract these two elements which are assigned to A1 and A2. So remaining elements are n minus 2. For example, A1 is assigned B2 element and suppose A2 is assigned B1 element, then we cannot use B1 and B2 as images of A2. So we have to subtract these two elements from total number of elements, that is n minus 2. Similarly for fourth element we cannot use these three elements which are assigned to A1, A2 and A3. So for A3 there are n minus 3 images. Similarly for A5 we can have n minus 4 possibilities. We cannot assign elements which are assigned to A1, A2, A3 and A4. There are 4 elements already assigned to A1, A2, A3 and A4. So we have to subtract those 4 elements for this A5. So value of the function at A5 can be selected in n minus 4 ways. So you can generalize this, you can understand the pattern here. If I have 1 here, then I can write this as n minus 0 or n minus 1 minus 1. Similarly, this 1 I can write as n minus 2 minus 1. So if I have 2 here, I consider n minus 2 minus 1. I am rewriting this 1 as 2 minus 1. Similarly, here this 2 I can write as 3 minus 1, that is n minus 3 minus 1 ways. Similarly, n minus 3 can be written as 4 minus 1. So you can understand the pattern here. Here 4 can be written as n minus 5 minus 1. So if I have 1 here, I subtract 1 minus 1 from n. If I have 2 here, I subtract 2 minus 1 from n. If I have 3 here, I subtract 3 minus 1 from n. If I have 5 here, I write n minus 5 minus 1. So in general, suppose I am interested in the image of kth element ak, then the number of ways we can assign value to ak will be n minus k minus 1, and possible values of k are 1, 2, 3 up to last element is mth element. There are m elements. So the value of the function at first element can be selected in n ways, that is n minus 1 minus 1. The value of the function at second element can be selected in n minus 1 ways. Value of the function at third element can be selected in n minus 2 or n minus 3 minus 1 ways. The value of the function at fourth element can be selected in n minus 3 or n minus this 4 minus 1 ways. And similarly, value of the function at fifth element can be selected in n minus this 5 minus 1 ways. In general, the value of the function at kth element can be selected in n minus k minus 1 ways, and possible values of k are 1, 2, 3 up to m. So now we can see that our procedure is to count the number of one-to-one functions from set A to set B, and this procedure can be broken down into m different tasks, because we have to assign elements of set B to each element of set A, and there are m elements in the set A. So this procedure can be done into m different tasks, say T1, T2, T3 and so on up to Tm. Task 1 is to find the number of ways of assigning elements from set B to first element. So that we have, as we have discussed, it is n minus 1 minus 1 ways. That is simply n ways, but we are rewriting in this way. Task T2 is assign element of set B to second element, and that we can do in n minus 2 minus 1 ways, or simply n minus 1 ways. Task T3 is assign element of codomain to the third element, and that we can do in n minus 3 minus 1 ways or n minus 2 ways, and so on. Task Tm is assign element of set B to mth element of set A, and that we can do in n minus m minus 1 ways, or that is simply n minus m plus 1 ways. So by the product rule, our task can be completed in n into n minus 1 into n minus 2 into n minus m plus 1 ways. The number of ways of doing task T1 is n, the number of ways of doing task T2 is n minus 1, then n minus 2, and so on, n minus m plus 1. So these are the possible number of one-to-one functions from set A having m elements to set B having n elements, and with this condition m is less than or equal to n. So this is very interesting example. We have written all these things systematically. We have to write down this as a possibility, two possibility. We are considering two cases. First case is if m is greater than n, there are no one-to-one functions from a set with m elements to a set with n elements. Second case is if m is less than or equal to n. So in that case, we write that suppose the elements in the domain are a1, a2, a3 up to am. Now, as we have discussed, we can assign n images to first element, or we can write that there are n ways to choose the value of the function at a1. That is, we can assign a1 as any of these n images b1, b2, bn. So there are n ways to choose the value of the function at a1. Now we have to take care that our function is one-to-one. So since the function is one-to-one, the value of the function at second element can be picked in n minus 1 ways, or simply we cannot use the value assigned to a1 for this a2 because our function is one-to-one. So a1 will be assigned any one of these values. So we will subtract that assigned value to a1. So for b2, for a2 there are n minus 1 images possible. So that we have to write in this way. Since the function is one-to-one, the value of the function at a2 can be picked in n minus 1 ways. And here we have written this reason that why there are n minus 1 ways for a2, because the value used for a1 cannot be used again. Similarly, the value of the function at third element can be chosen in n minus 2 ways. Why? Because the values used for a1 and a2 cannot be used again. So we have to subtract those two values which are assigned to a1 and a2 from total number of possibilities, which are n. In general, the value of the function at ak, that is kth element, can be chosen in n minus k minus 1 ways. So before assigning value to ak, we have to subtract the values which are assigned to k minus 1 elements. Before assigning value to ak, we have to take care that which values are assigned to a1, a2 up to ak minus 1. So these are k minus 1 values. So these we cannot assign to kth element. So we have to subtract those k minus 1 values from n. So for ak there are n minus k minus 1 images possible, and k can take the values 1, 2 up to m. And therefore by the product rule there are n into n minus 1 into n minus 2. Last element was am. So for am we can assign n minus m minus 1 values, and this we can rewrite as n minus m plus 1. So by the product rule there are n into n minus 1 into n minus 2 up to n minus m plus 1 one-to-one functions from a set with m elements to a set with n elements. So in this way we can count the number of one-to-one functions from set having m elements to set having n elements, and answer is n, n minus 1, n minus 2, and so on. Last one is n minus m minus 1. So this is very interesting question. Instead of these arbitrary numbers, they can give you particular numbers also. Suppose number of elements in domain are 3 and number of elements in codomain are 2, then here m is greater than n. So in this case there is no one-to-one function. But suppose here number of elements in the codomain are 5, then we can use this formula to count the number of one-to-one functions from set having 3 elements to a set having 5 elements. So for example, we can start with 5. Okay, we can use this formula. N is 5, so 5, then n minus 1, that is 4, then n minus 2, that is 3, and we should count this first, n minus m minus 1. So m minus 1 is n minus 2. So we will stop here. Okay, first we count this, n minus m minus 1, n is 5, m is 3. So we have n minus 2 as the last factor here. So n is 5, n minus 1 is 5 minus 1, that is 4, n minus 2 is 3. So there are 60 one-to-one functions from a set having 3 elements to a set having 5 elements. So this is very interesting problem, and I have tried to explain you. I hope you understand. If you have any doubts, you can ask your doubts in the comment section. So this is all about this session. Thank you very much.